This video is about operators in Java. An operator is basically a symbol or token. Operators works on operands, means values, to give meaningful result. Types of operators. One is unary operator. Second one is arithmetic operators, logical operators, relational operators, ternary operators, bitwise and shift operators, assignment operator. So first we talk about unary operators. Unary operators perform operations on only one operand. Types of unary operators. Unary plus operator. It is applied before the operand int a equals plus 10. We know if a value is positive, it don't need plus sign. It means a equals 10. So here, what is operand? Here 10 is operand, means a value or a variable is used or as a term of operand. So operand is a value or a variable. Next topic is unary minus operator. It is applied before the operand int a equals minus 10. That means a holds negative value. Next one is unary plus plus, means increment operator. It is applied before the operand, increase the value by not 10, that is value by 1. Again a mistake, sorry for that. Example, int a equals plus plus 10. It means value of a is 11. Unary minus minus, decrement operator. It is applied before the operand, decrease the value by 1. Int a equals minus minus 10. It means value of a is 9. Logical operator. This is an operator is applied when you want to reverse the outcome of an expression. Here use if not 8 greater than 3. 8 greater than 3, it is true. But in that case, if returns false, because 8 greater than 3 true, but I use logical operator. Okay, that is logical not. So it will give you false. If 5 greater than 7, it is true. 5 greater than 7 is a false concept, but as a logical not sign is provided, so answer is true. So that is the about unary operators. Next topic is prefix increment or decrement. First, update. Update means increase or decrease the value by 1. The value of the variable, then use the update values. First update the value of the variable, then use the updated values. Okay, example, int p equals 11. So p equals plus plus p into 2. That means p equals 12 into 2. Here p is 11, but plus plus p means first update the value. That means p value have to increase by 1, then multiplied by 2, and you will get 12 into 2, 24. Another example, p equals minus minus 2 into 2. So here p is 11, so minus minus p, that means 10. 10 into 2, answer will be 20. Another topic is postfix increment or decrement. Postfix means after the operand. Prefix means preposition, or like first part or previous part of the operand. First use the last value of the variable, then update it. Okay, update means increase or decrease the value by 1. If you have example int p equals 11, that means p equals p plus plus into 2. So first use the last value. The last value of p is 11, so here p plus plus means 11 into 2, so answer will be 22. So if you think p equals 11, p minus minus, use the last value, that is 11, 11 into 2, answer will be 22. Now I use a complex statement where everything is used. That you can see a plus plus, this is a postfix plus plus a prefix increment. This one is a minus minus, that means postfix increment, minus minus a, it is a prefix decrement. Postfix increment, prefix increment, postfix decrement, prefix decrement. Okay, so what is the calculation? Here a equals this into this multiply is placed at here, means the total value is multiplied with another a, that means the value of a is 6, so this total value is multiplied with 6. So after leaving this part, a plus plus by 6, so last value of a is 6, so 6 by 6 means a plus plus by 6 plus a, that will be 8. How? A plus plus means you store the use the last value, that is 6, and in the memory value will be updated. Okay, so value will be 7 at that location, and here plus plus a, that means 7 incremented by 1, that means here we use the value of a is 8, so 8 mod 3 plus 8 multiply 3, 2. Here this is a postfix decrement, means use the last value. Last time a will be 8, so 8 into 2 plus, after using the value of 8, decrease the value, so it will be 7, and here prefix decrement, that means 7 again decremented by 1, so that is the value of 6. So that is the answer. A equals, the sign is not here, a equals 6 into 6 by 6 by 1, 8 mod 3 is 2, 8 into 2 equals 16, and 6. So finally a equals 6 into 25. So finally a equals 150 is the final answer. Next, arithmetical operators. An arithmetical operator which deals with two operands. It means two variables, two values, anything. So first part is addition. Symbol is plus, format a plus b, find add both operands. So if the value is 23 and b equals 5, the answer is not 29, it is 28. Subtraction. A minus b, find and subtract both operands. 19, no, it will be 18. Actually I mistake, I use 24 here, but mistakenly it will be 23 in the part when I edit the PowerPoint slide. So multiplication, that is the asterisk sign, we all know. A into b, find the product, so it will be 120. A is 24. Division means find the quotient. 24 by 5, it means we get a fractional value, but here division holds. If we use integer variable, it will be just quotient without any fractional part. Okay, I use 4 here, thinking about I want to hold only integer part, that's why I use 4, otherwise it will be 4 point something figure. Yeah, 24 by 5 something figure. Okay, modulus, it will be remainder value. 24 mod 5, 24 mod 5 means 20 divided by 5, so 4 is not divisible by 5. Okay, so the remainder will be 4. So many mistakes by me, sorry. So addition will be here 29, 24 plus 5, 24 minus 9, 5, it will be 19, 24 into 5, it will be 120, 24 by 5, it will be 4 point something, but I here use 4 as int, and 24, but last I use 23 mod 5, so answer will be 3. So that is all about arithmetical operators. Now relational operators. It shows the relationship between the operands. It compare values of variable and result in terms true or false. Just check less than sign. A less than B checks A is less than B or not. Okay, so it will give you 23 less than 5. No, it will give you false. Greater than A greater than B checks A is greater than B or not. It is true because 23 greater than 5. Less than or equal to 24 less than equals 5 checks A is less than or equal to 5. It is false because A is not less than not equal to 5. Greater than or equal to 24 greater than equals 5. Yeah, it is true. Checks A is greater than or equal to B or not. It is true. Double equals or equal to sign. A double equals B checks A is equal to B or not. It will return false in that code. Not equal. Not equal to. A not equals B checks A and B both are not same. Double equals checks same. Not equals check not same. It will be true in that case. So now topic is logical operator. It shows the relationship between the operands. It compares values of variables and result in terms of true or false. Logical OR. This operator is used to combine two or more conditional expressions. It will result true if any one or more condition is true. Otherwise false if none of the condition is true. Means you have to true one condition, minimum one condition to execute this part. So here is the example. If 4 greater than 8, 9 greater than 6. In that case 4 greater than 8 is false, but 9 greater than 6 is true. That means if part is executed. If I take another example, 5 less than 2, false. 3 greater than 7, false. 6 less than 1, false. It means result will be false as all conditions are false. Means you need minimum one condition to execute this if. Logical AND. This operator is used to combine two or more expression or conditions to such a way that it result true if all expressions are true, otherwise in false. If 4 less than 8, true. 9 greater than 6, true. Result is true as both condition is true. Another example, if 5 greater than 2, okay. 3 greater than 7, not okay. 6 greater than 1, 7, oh, 6 greater than 1, okay. In that case, 5 greater than 2, true. 6 greater than 1, true. But 3 greater than 7 is false. That means the if is not executed. Sorry, I have to edit it. This is too much. Sorry guys for these things. So I made the changes is about 23, it will be 28, it will be 18, it will be 1, 1, 5. I think this editing is better, and this one logical not. So this is arithmetical corrections, that is logical, and that one is logical and. Okay, so you have to write double and look like this. Just wait a few seconds. Logical and. Here you see double line, and here you see double and. So that is the logical and logical or. So another one is ternary operators. It deals with 3 operands. Value assigned to a variable depends upon a condition. That is the short definition of ternary operator. This operator also known as a conditional assignment statement. Possibilities. If condition is true, then value of expression 1 assigned to the variable. If the condition is false, then value of expression 2 assigned to the variable. Okay, if you think now, you think what is the expression 1, what is the expression 2, what is the condition, just wait. So that is the syntax or rules. Variable equals condition, that is the condition part. Expression, this expression 1 and the expression 2. Now see the example. Int a equals 10, b equals 45, max and mean. I write max equals, if that is the condition, a greater than b, answer is false. Yeah, then as the condition is false, so this one, take this one. If condition is false, then the value of expression 2 assigned to the variable. So b is initialized to max. What is the value of b? That is 45. So max equal 45 as condition is true. As condition is true. As condition is false. So expression 2. And in that case, mean equals a greater than b. So this part is condition is true. So mean equals 10 as condition is true. As condition is true, so expression 1 will be answer. Now see another. Int a equals 23, b equals 29, c equals 35 max. Okay, here I use complex or multiple ternary concepts. So first I check if a greater than b. Next, inside of that a greater than c, and again b greater than c. So finally I get max equals 35 as a greater than b false. As a greater than b false, that means the value check in that area. Okay, see, there are two parts, this one and this one. Okay, so as a greater than b part is false, then the process goes to expression 2. That means now you have to check b greater than c. Answer will be false. So c is initialized to max. Okay, that is the ternary operator. Next, bitwise and BitShift operator. Actually bitwise and BitShift not using too much in our programming language. but a little bit concept needed, so I give it. Bitwise and BitShift operator are used on integral types byte, short, int, long to perform bit level operations. Mainly it is holdings like binary figures, means we know binary value about 0 and 1, it cannot it holds only 0 and 1, so it will use for these operations basically. Just accept the decimal number. Now you have to convert it in binary form, then you can use Bitwise and BitShift operators. Let's check types of operators, means those are the signs. There are not the type of, there are the signs, different signs, means a single line, straight line, I think this is a vertical line, bitwise or and bitwise and, that the sign is known as complement, so here use as bitwise complement, that is a XOR, bitwise XOR, left shift, right shift, unsigned right shifts. So bitwise operators. First, bitwise OR works on two operands, compares corresponding bits. If either of bit is 1, it gives 1, if not, gives 0. The table is like that. If we accept a decimal number, that is 13, so the binary form 13 is 01101. And if we want to use OR sign with 24, means 13 bitwise or 24. So what is the bit 24 binary value? 11000. So if you use OR sign, it means 0 and 1, 1, 1, 1 become 1, 1, 0 becomes 1, 0, 0 becomes 0, 1, 0 becomes, means if you have a single 1 in that part, it will give you 1. If you have both 0, the answer will be 0. And now the final answer 11101. Now we can convert the binary form into decimal, if we get 29. Next one is bitwise AND. Works on two operands. It compare corresponding bits. If both bits are 1, it gives 1. If either bit is not 1, it gives 0. Now see, 0 1 becomes 0, 1 1 becomes 1, 1 0 becomes 0, 0 into 0, 1 0 becomes 0. Just very clear, when you use bitwise OR, just plus, but 1 plus 1 becomes 2, but don't use more than 1. That means in that case you add, in that case you use multiply sign. Here use plus sign, here is multiply sign. So 1 into 0 becomes 0, 0 into 0 becomes 0, 1 into 0 becomes 0, 1 into 1 becomes 1, and 0 into 1 becomes 0. That is 01101 is the decimal value, 13, 11000 is the binary form of 24. So finally I got 01000. That means it becomes 8. Next one is bitwise complement. Works on one operand, inverts the bit pattern, it makes 0 to 1, 1 to 0. So just one operand, that is 29. The binary form is 11101. So if you use bitwise complement in that 29, you will get 11010, as 1 inverted at 0, 1 inverted 0, 1 inverted 0, 0 becomes 1, 1 becomes 0. So final value of 0010 becomes 2. That is bitwise complement. Just convert the value. 0 becomes 1 and 1 becomes 0. Finally, bitwise XOR works on two operand. If corresponding bits are same, it gives 0, else it gives 1. Just see. Let's see. 0 1 becomes 1. Where is mouse? 1 1. Bits are same. Answer will be 0. If corresponding bits are same, it gives 0. So corresponding bits both are 1 1. That means 0. Here 0 0. That means 0. Otherwise, if you have different values, 0 1 becomes 1, 1 0 becomes 1, 1 0 becomes 1. So 13 is the decimal value of 24 decimal value binary value, and the binary value of is 10101, and the decimal value is 21. Now bit shift operator, that is signed left shift. It shifts a bit pattern to the left by certain number of specified bits 0, and 0 bits are shifted into the bit pattern from right side. So I use 25 left shift 1. So I use 25 decimal value. The binary form is 11001. So you have to add a 0 from this part. Just see, 11001, 11001. You have to add 10 because I use certain number of specified bits. As I use 1, then only 10. So the answer will be 50. Now you convert 110010, you will get decimal value of 50. In that case, see, what is the value of 13? 13 binary form is 1101. Just see, 1101 is at here. Add 20 from the right side. Okay, because here is the specified element is 2. If there is 3, then you have to add 30 from the right side of the bit pattern. So that is signed left shift. Now signed right shift. It shifts a bit pattern to the right by certain number of specified bits, means delete specified from bits from right side and shift bits towards right. Just see, 35 right shift 1, 100 10011 is the binary form of 35. Now delete this one as there is only 1. So I delete this one. So answer will be 10001. So finally 10001 will be the binary value, and the decimal value is 17. So if I use 52 and signed right shift 2, it means we have to delete last 20 shifted 2 times as mentioned to here. So 110100 to 52. So after deleting 20, that means 1101. Last one is unsigned right shift. It shifts 0 into the leftmost position, means add 0 bits from left side and shift bits towards right. Just see, 50 unsigned right shift 1. So 110010 equals 50. Use a 0. It means a kind of shifting, or you can say it will. It looks like this signed right shift almost, but in that case you have to delete, and in that case you have to add 0. And now you say the no value 0 has doesn't value. It doesn't matter, but you have to add 0 in that locations. So here I use 1, that means I have to add 10, and here 3, that means I have to add 30. So 110010, that is the binary form of 50, and after adding 3 zeros here, the number will be 110. So that is the 6. So now final part is precedence of operator. In mathematics we use Bodmer's system of hierarchy, but in computer we apply Bemdas, means bracket, exponent, division, multiplication, addition, subtraction. Okay, you can say multiple division or Bedmas, almost same. So that is the hierarchy. Okay, first bracket, the separators. First you have to use separators, then array signs, then prefix, not the prefix, that is unary operators, unary plus plus, unary minus minus, complement, not, that is the second precedence. Then multiply, division, and percentage sign 3, plus minus, those are shift right shift, you know, greater than, less than, greater than equals, less than equals, double equals, not equals. Other part is and at 8 or 9, not 10, and double and, double or, not equals, equals. So that is the precedence. You have to maintain. And one more thing, operators having same precedence means the operator which appears first from the left side of an expression will be operated first. Means in an expression, if you got multiplication, division and mod in a same line, first you have to do multiply, then you have to do divide, then you will be able to use the mod sign. Okay, so that is the end of the operators. Bye bye.